Okay, this lesson is section 2.4, and it's going to be about circles. And so I thought we'd begin by looking with the definition. I'm on page 185 in your book, and it says a circle is a set of points in the XY plane that are a fixed distance r from a fixed point HK. The fixed distance r is called the radius, and the fixed point HK is called the center of the circle. Well, what that means is you have a group of points that are the same distance from this point HK, and we call HK the center, and that distance is called the radius. It goes on to say below that the standard form for the equation of a circle is this, where H and K represent the center. Notice that it's X minus H and Y minus K. Those minus signs are going to come into play. It also talks about the general form of the equation, so I wanted to go ahead and show you how they get that. If you take this binomial and multiply it by itself, which is what it means to square it, and simplify it, you get this. And if you take this binomial and square it and simplify it, you get this. So I replaced these two parts with these two. And that's how I got this line right here. Well, to be in general form, the right-hand side needs to be 0, and things need to be in a special order. The x squared, then the y squared, then the x term, then the y term, and then the constant, and then equals 0. And so what they did was rewrote that where they don't use minus 2h, they just call it a, and they don't use minus 2k, they just call it b, and all these numbers won't have any variables in it, they'll just be numbers, and they group all that together and call it c for the constant. So when they ask us for the equation in standard form, that's going to be this. When they ask for the equation in general form, that's going to be this. And the way you go from standard to general is to multiply it out. Now when you actually have numbers here, the multiplying it out will look a little bit easier. But I'll show you that as we go along. Alright, so the first problem we're looking at is problem number 9, and it's asking us to find the center and the radius. Well, they don't have the grid drawn, but I see right here this point is 0, 1, and this point is 2, 1. So that means that length of that line is 2, because it went from 0 to 2. So that's my radius. And I can see in the picture that the center is 2, 1. So let's write that down. We can count that the radius is 2 and the center is the point 2, 1, just from the picture. And so the directions are to write it in standard form. That's this form right here, where we just fill in the h and the k and the r. And remember, it's minus. So I'm going to do x minus 2 squared, that's for this 2, plus y minus 1 squared, that's for this 1, equals 2, that's this 2, squared. And you actually go ahead and square that. And so this would be my answer for number 9. That would be the equation in standard form. Now, let's look at problem number 11. You see that this point is at 1, the x-coordinate is 1, and you see that this x-coordinate is 4. Well, if you count from 1, 2, 3, 4, that's a distance of 3 spaces. But I only need half of that to find the center. So half of 3 is 1 1/2, or 3 halves. So what I'm going to do is figure out how to get all this paperwork in here. I have the point 1, 2, and I can see from the graph that the y-coordinate is going to be the same. The center, the y-coordinate of the center is going to be 2 because they're all on that horizontal line. So for my center, the y-coordinate is going to be 2. But for my x-coordinate, I need to add 1 1/2 to this. So I'm going to add 3 halves to 1. 1 is 2 halves, so 2 halves plus 3 halves makes it 5 halves. And that's going to be my center. Now, how far is it from this point to this point? It's 3 halves. So my radius is 3 halves, and that's going to be easier to square if you leave it as an improper fraction. So now, to write my equation, I'm going to do x minus the x-coordinate squared plus y minus the y-coordinate squared, and that's going to equal the radius squared. So x minus 5 halves squared plus y minus 2 squared. And when you square a fraction, you just square the numerator and square the denominator. So there's my answer in standard form for that problem. Now, the next group of problems are starting on page 189. Notice they want it in standard form and general form. So we're going to do both ways. And the first one we're looking at is number 13. And we're told that the center is 0, 0, and the radius is 2. So that's going to be x minus 0 squared plus y minus 0 squared equals 2 squared. X minus h, this is your h, and this is your k. Well, x minus 0 is just x. So when you square it, you just get that. And y minus 0 is just y, so that's just y squared. So that's a little shortcut that you can do. If the center is 0, 0, you can just go straight to x squared plus y squared equals r squared. Because if the center is 0, 0, you're going to always get x squared plus y squared right here. Now, to be in standard, that is standard form. To be in general form, this side has to be 0. So all I have to do is subtract that 4. And that makes my answer in general form. Okay? Now we're going to move on to number 15. And we're told that the center is 0, 2, and that the radius is 2 again. Alright, so x minus 0 squared plus y minus 2 squared. Remember, this 2 is what's going right here. And then this 2 is what we're going to square for the radius. Again, x minus 0 is just going to be x. Okay, so that is my answer in standard form. Now I need to write it in general. Well, this one there's nothing to do except copy it. This one I need to multiply y minus 2 times y minus 2. That's how you square a binomial. And when you do that and simplify it, you're going to get y squared minus 4y plus 4. So this part right here came from squaring that binomial. Now, for it to be in general form, this side's got to be 0. So I'm going to subtract 4. That's going to become 0, and that's going to become 0. So this is my answer in general form for that particular problem, for number 15. I'm pausing in case you need to write something down, so I'm letting you work on that. Alright, the next one we're going to look at is number 15. That was number 15, sorry. Number 17, where the center is 4, -3, and the radius is 5. Alright, remember it's x minus h squared plus y minus k. What's going to happen when you subtract a -3? Subtracting a -3 is going to make it be a plus. And by the same token, you're going to come over to the side and multiply x minus 4 times x minus 4. And you're going to multiply y plus 3 times y plus 3. And when you multiply x minus 4 times x minus 4, you're going to get x squared minus 8x plus 16. And then when you multiply this, you're going to get y squared plus 6y plus 9. And when you square that, you're going to get 25. Now, remember when I showed you at the beginning, when we put it in standard form, we do x squared, y squared, then x, then y, then number. Okay? So my next step is going to be to do two things. To get this side to be 0 and to get it in the right order. So I'm going to copy this x squared. So I use that term. I'm going to copy this y squared. So I've used that term. I'm going to copy this minus 8x. I'm going to copy this plus 6y. And now I've got this 16 and this 9 and this minus 25 that I'm subtracting so that this side will be 0. Well, when you do the math, that all becomes 0. Now that doesn't always happen, but it has for the last two problems. So there's my answer. This is my answer in standard. This is my answer in general. Now, I'm going to go to number 21, where the radius is 1/2 and the center is the point 1/2, 0. So I'm going to have x minus 1/2 squared plus y minus 0 squared equals 1/2 squared. Okay. So when you write this down, x minus 1/2 times x minus 1/2, you're going to get x squared minus x plus 1/4. And y minus 0 is just going to be y. And then this is going to be 1/4. Because when you square a fraction, you square the numerator, square the denominator. So 1 times 1, 2 times 2. Alright, so now we've got to get it in the right order, and we've got to make this side 0. So I need this y squared to come down here. I'm not subtracting it because it's on the same side of the equal sign. I'm just moving its position. And when I subtract this 1/4, I get 0 again. Now, y'all need to know that doesn't always happen, but it's happening with these problems. Often there is a number right there, but for this group that we're looking at, there hasn't been a number. Okay? Now, let's see where we're going next. Okay, next we're going to problem number 25, and they asked me to tell what the center and the radius is and find the intercepts. Okay, and graph it. Oh Lord, there's a bunch going on there. Alright, so let's first look at what the center is. Notice there's nothing with the x, so that means the x coordinate of the center is 0. There's nothing with the y, so that means the y coordinate of the center is 0. And because the square root of 4 is 2, it means the radius is equal to 2. That came from taking the square root of 4. That's an R. So my center is 0, 0, and my radius is 2. And then for my intercepts, well, think about where 0, 0 is, right here. So where is it going to hit the x-axis? That's the center. So we've got to figure out what this point, and this point, and this point, and this point are. Where does it hit the axis? So you remember, to find the x-intercept, I let y be 0 and solve for x. So when I let y be 0, I get x squared plus 0 equals 4. So x squared equals 4. And remember, when you take a square root, you get plus and minus when it's something like this. Now up here, I only use the positive because you can't. It doesn't make any sense to have a negative value for a square root. But here, when we're talking about intercepts, you can have a negative value. Alright, so for the y-intercept, you're going to let x be 0 and solve for y. And you're going to get the same thing, y equals plus or minus 2. So it depends on how they ask you to write them, whether they want you to write numbers, whether they want you to write ordered pairs. And y'all need to pay close attention because that's what the problem was on the quiz. Several of you didn't pay attention to what the directions were. So this one, if they ask for an ordered pair, would look like that. And this one would look like this. But I haven't looked yet to see if they want the numbers or the ordered pairs. But if it wants an ordered pair, it'll say, write your answer as an ordered pair. Okay? Now, we're going to come back to the graphing in a minute. I'm going to deal with that later. But right now, we're going to move on to the working them out part. So this is number 26 that you can't see because I have my paper up too high. So there's nothing with the x, so that means my center, my x coordinate is going to be 0. And what's with the y is a minus 1. Remember, the equation has a minus in it. So you take the opposite of that to get this. And then for the radius, you take the square root of 1. Well, that's square root of that 1, which is just 1. So there's my center and there's my radius. Now, for the x-intercept, we're going to let y be 0 and solve for x. That's going to be negative 1 squared, which is going to be 1. And when I subtract 1 from both sides, I get x squared equals 0, so x is going to be 0. Then, when I let x be 0 and solve for y, that goes away. Oops, sorry. That goes away. So I have y minus 1 squared equals 1, and you can take the square root of both sides. So I get y minus 1 from this equals plus or minus 1. So when I add 1, I get y equals 1 plus 1 and y equals 1 minus 1. Well, this one gives me 2 and this one gives me 0. Alright, so let me see if I can find a piece of graph paper. Doesn't have a graph on it yet. Here's one. Let me kind of show you what that's going to look like. The center is 0, 1. And it's going to hit, it's a radius of 1. So it's going to go 1 here, 1 here, 1 here, and 1 here. And then you give it your best effort at making it look like a circle. Alright, does this match what we think? We thought it should hit the x-axis at 0, and it does. And we thought it should hit the y-axis at 0 and at 2, and it does. So that's what that circle would look like if you were to draw its graph. Alright, now we're going down to number 39. And we're told that the center is at the origin. And there's a point on the circle, -2, 3. Alright, so let's see what that looks like. Can I find one that doesn't have anything on it? No. Alright, let me draw one real quick here. Alright, so what does that mean? This is what we're given. The center's at the origin, and the point -2, +3 is on the circle. So it means that my circle looks something like this, sort of. Well, to write the equation, I have to know the center and the radius. Well, I got the center. That's 0, 0. But the radius is the distance from the center to any point. Well, how do I find the distance between 2 points? Oh, yeah, the distance formula. We had that, didn't we? So I need to find the distance from the point 0, 0 to the point -2, 3. So my good old distance formula, the square root of x minus x squared plus y minus y squared. So I got square root of 13. Alright, so what were my directions? Write the standard form. Here's my center. So since it's 0, 0, I can just do x squared plus y squared. Here's my radius that I square. Well, what happens when you square the square root of 13? You just get 13. So that's my answer to that problem. Alright, now, number 41 says we have a diameter. You know, diameter is the line that goes through the center and goes all the way across the circle, where the radius just goes halfway from center to side. Diameter goes all the way from side to side. So let's see what that might look like. We have the point 1, 1, 2, 3, 4, and the point -3, +2. So imagine a circle that's going like this so that it hits these 2 points. So maybe it looks something like that. Well, we need the center and the radius. Well, where is the center? It's halfway in between these two. It's like right in here somewhere. Well, how do you find the point halfway in between 2 points? You find the midpoint. So what I need to do is to find the midpoint of these, and that's going to be my center. Well, how do you find the midpoint? You add the x coordinates and divide by 2, and you add the y coordinates and divide by 2. So 1 plus -3 is -2. divided by 2 is negative 1. 4 plus 2 is 6, divided by 2 is 3. So I'm saying the point negative 1, positive 3. Well, I got it pretty close, didn't I? Look, there it is right there. So that's going to be my center. Well, I still need to know a radius. So I need to know the distance, either from this point to this one, this point to this one, or I could do from here to here and take half of it. But I'm just going to go from negative 1, 3 to this point, which was 1, 4. And I'm going to find the distance from negative 1, 3 to the point 1, 4. So distance is equal to the square root of x minus x squared plus y minus y squared. 1 minus negative 1 is 1 plus 1, so that's 2. Squared is 4. 4 minus 3 is 1. Squared is 1. 4 plus 1 is 5. So the distance between the center and a point on the circle is the square root of 5. So how do I write the equation? X minus h, remember h was negative 1, x minus h squared plus y minus k squared equals r squared, because this represents my radius. Well, x minus negative 1, that's just going to be x plus 1, and y minus 3 squared, and square root of 5 squared is 5, and that's it. That's my answer in standard form, and that's all they asked me for on that problem. Okay, the last problem in this group is the group that's from 45 to 48. And 45 has an equation, y'all can't see me right. I'm just copying the equations out of the book. Oh, this is not 45 for 6 or 7. This is A, B, and C. Sorry. We're going to match these up with those. Okay. Now, we might need to be concerned about the radius, but probably all we're going to need to be concerned about is the center, because this is a matching game. Remember, I told you you're going to take the opposite of these. So the center for this one is going to be 3, 3. Take the opposite. The center is going to be negative 1, positive 2. This center is going to be positive 1, negative 2. And this center is going to be negative 3, positive 3. Now, what we want to do is compare those centers with those 4 graphs. Let's see how we can do that. There we go. So think about where the point 3, 3 is. That's not the center of that one. 3, 3. No. 3, 3. No. That one's not either. Did I copy something wrong? I surely did. Okay, none of them match up because I copied this wrong. Alright, go back and fix this. Back up here. Choice A, that was a plus, which is going to make that a negative 3 right there, because I told you you take the opposite. I'm sorry, I copied that wrong. So make sure you get that corrected. So that center's 3, negative 3. 3, negative 3. So that's going to go with number 48. Alright, so then I have a center of negative 1, positive 2, negative 1, positive 2. Negative 1, positive 2. It could be that one. It could be that one. Okay, let's come back to that one. Then I have a center of 1, negative 2. So let's see, 1, negative 2. That's got to be that one, 45. Alright, so now I've got to decide which one of these is negative 1, 2, and which one is negative 3, 3. So I need to count 1, 2, 3, 1, 2, 3 versus 1, 1, 2. And if you look at it more closely, you can see that this one is the negative 3, positive 3. And you can see that this one is the negative 1, positive 2. And that's all it asked you for in that group of problems, was to match these four graphs with those equations. Alright, that's the end of this part of how you do the algebra part. I'm going to do another video where I show you on my math lab how you're going to draw the graph of a circle. So this is the end of this video, but be sure you watch another one about how to do the graph.